Okay, so today's lesson's on section 2-2. This is the last section we're going to cover before you guys take the quiz on Friday. Tomorrow will be your day of review. So, the main gist of this whole section is talking about subsets. The first thing you need to write down about subsets is the notation looks something like this. Set A is a subset of B. It looks like a capital U that's on its side, like it fell over. Okay? And it has a little equal sign underneath it. Okay? It's like similar to less than or equal. It has that little sign underneath it, okay? And this reads like the following. A is a subset of B, so every element of A is an element of B. Okay? An example of that would be this set. 1, 3, 5, and B set 1, 3, 5, 7. We can say A is a subset of B. Notice that 1 is in both of them, 3 is in both of them, and 5 is in both of them. Okay? So A subsets B. How about this one? X such that X is a letter in the word roof. Okay? And B is Y such that Y is a letter in the word proof. Does A subset B? Yeah, because roof is really a part of proof.
If the equality sign was switched, it would be false, though.
Correct. If it were in the other direction, I could not say B is a subset of A, but I can say that A is a subset of B. Okay? All right. Another example of this would be X such that X is a day of the week. And B is a set that has Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Does A subset B? Yeah, it does. We can also say that A is equal to B, right? When we talked about equality rules yesterday, they have the exact same elements in it. I could also say B subsets A, because they are equal. All right? One thing else I could say about this is that every set is a subset of itself. Okay, so A is a subset of A. Then we have something called a proper subset. And Blitzer says that A is a proper subset of B. Notice there's no equal line underneath it. A is a proper subset of B when all the elements of A, is in B, but A and B are not equal. Okay? So it's very similar to the above that we've been doing. But in this case, you know that A and B are not equal.
So without the equal sign, the bottom part of the equal sign under the greater than or less than sign, it means, what is the difference between adding the line under the greater than
Yeah.
sign?
The line says it's possible that it's equal. So this one up here, right here, is saying A is possibly equal to B. This one down here says A is not equal to B, but A is a subset of B.
Okay.
Okay?
So the top one means is possibly equal or a subset to me.
Yep.
Okay.
Yep.
See.
Okay. So let's look at another thing. In your homework for today, there is something that does this. How does that read? Yep, 4 is an element of 4 and 8, of the set of 4 and 8. This one reads a little different. This one reads the subset of 4, the set of 4 is a subset of 4 and 8. Okay? Now, you're going to be looking at ones like this in your homework. Do know that this is different. Because 4 itself, without the brackets on it, is not a set. So it can't be a subset. Okay? So we can't do that. But the other two are true. So you're going to have some questions like that on your homework today. Question. If I have a set that's empty, and I have B as a set that has 1, 3, and 5 in it, is A a subset of B? And that's the common guess. So far, all morning this morning, everyone said no, it's not a subset. But actually, the rules are that it is a set. Okay, so an empty set is always a subset. Okay, so in this case, A is a subset of B, and an empty set is always a subset of B. Okay? So that counts. Go on. So in this next part, I'm going to write on here. You don't need to write this down because it is on your book on page 62. It's a chart that I'm going to write out. And let's see if you guys see the pattern. If we have a set and the number of elements for the heading for the chart, list of subsets, and number of subsets. Okay, so my first set is an empty set. How many elements do I have in it? 0, correct. Okay, do you guys know what the subset of this set is? It can be itself, right? We already said that every set is a subset of itself. So how many subsets do I have? 1. Okay, what about this one? How many elements do I have? 1. the list of subsets can be an empty set, and it can be a set with A in it. So how many subsets do I have? 2. If I have the set of A, B, how many elements do I have? 2. And my list of subsets? Empty, A, B, and AB. So how many subsets do I have? 4. Next one is A, B, and C. How many elements do I have? Yep, you're right. Yeah, we're going to 8. So this is 3 elements. We have an empty set, an A, a B, a C. Yep, A, B, B, C, A, C, and then last but not least, A, B, C. So that's 8. You guys start seeing the pattern here? So when I'm looking for number of subsets, I'm really looking at 2 to the power of the elements. Okay? So 2 to 0 is 1, right? 2 to 1 is 2. 2 to 2 is 4. 2 to 3 is 8. Okay, so if I want to know the number of subsets, and this is what you might want to write down, it is always equal to 2 to the n, where n is the number of elements. Back in a minute. Okay, here's the one thing though. If it's a proper subset, the number of elements is different. It never counts itself as a subset. Okay? So proper subsets never count themselves as a set. Themselves as a subset. Okay? So for instance, for A, so in other words, the formula for that would be 2 to the n minus 1. And I'm going to give you an example why that is. So here I have a subset of A, B, C, and D. Okay? So if I were looking at this as a regular subset, how many elements would I have? How many subsets would I have? Nope, 2 to the 4th. So that would be what? 16, right? Okay? But if I'm looking at a proper subset, if you know when we listed all the subsets and we actually wrote down the actual set as part of the subsets, that one is not counted.
So 15.
Yes. So then it would be 2 to the n, which is 2 to the 4th minus 1. So it would be 15 as a total of subsets. You guys see the difference in that one?